know exactly. It would just print somebody's forms twice. And because we were medical records and we were obsessive, we figured we had to solve this problem. So 2 weeks of thinking hard about where everything was locked and what was happening happened. Like with me and one other guy, just brains exploding every day trying to figure it out. Until our friend Aaron was like, just put a bunch of sleep statements in there. Very good idea. So eventually we figured out a place where if we put a sleep statement, it would print twice a lot. And then that helped us figure it out. And it turns out MySQL optimistic locks are each client connection to the server has a thread. Each thread can hold one opportunistic lock at a time. If you grab a new one, it will silently release the one you just had. That's not a documented feature, by the way. That's just a feature. So that was big fun, and we eventually, but 4 weeks of people's lives were wasted trying to figure this thing out. Because concurrency is hard. We did it right. We used a thing that we had used for years and years to try and do it. All the logic was right. We just didn't know that something underneath us was not doing what we thought it was going to do. This is more Juju related specifically. Juju, who knows what twisted is in Python? Okay, Wolf, and one guy in the back. All right, so Python.
Thanks a lot.
You get to be one guy in the back, Craig. Just deal with it. If you sat in the front, you wouldn't be one guy in the back. You'd have a name.
He'd be one guy in the front.
Yeah, guy in the front.
And I used to work with Wolf. So Twisted is a asynchronous programming library, so you don't have to use threads. You can just do everything asynchronously. The problem with Twisted and the problem with Juju is that when everything gets a chain of callbacks, if any of those things in the chain mutates this return value on the way back, or mutates the call value on the way down, the things underneath it change. And just as a fact of Python, depending on what modules get imported in what order, those callbacks might get added in different orders. If you have a combination of those two things going on, your head is going to explode. And I won't go into all the details because they're boring, but they're no fun. So Python has a disclaimer. Like, I am more of a Python programmer than a Go programmer. So I have lots of Python. I have spent a lot more time in Python world than I have in the Go world. I'm a Pythonista and not a Gopher. Although I think Go has a lot of advantages. So, processes are good because one of the problems with asynchronous and thread programming is that you have mutable state that gets mutated underneath you, and you don't know when, because threads and processes, threads particularly are bad about this, is that you have 2 lines of code, something else happens sometimes in between those 2 lines of code. And you don't know what happened. The OS just decided that it was going to switch context, do some stuff, switch back. You don't know when it's happening. You don't know where in your program it happens. You don't get to decide, oh, these 5 things happen all together, and then you can do other stuff. No. You have no choices. We're just going to do stuff. And that's just the way it is. And it's very hard to reason about threads. But processes, at least, you can't mutate state of anybody else. You only have what is in your memory, not anybody else's. And you have to have an explicit channel. And earlier I mentioned we use a network queue. That is a way to use an explicit channel to communicate. When you use an explicit channel, you can reason about, okay, something got put on that channel and then it got pulled off of that channel. What happened? When is going on? Like, there is a place for you to start thinking about how did this data change and where did it change? It can only change through explicit means. Whereas if it's just some junk laying around in memory, who knows when it changes or why? I mean, you have to know all of the code to know why, and you have to know when thread switching happened to know when. So it's very complicated. It is hard to reason about. And so the MySQL example, like it was threads internally to MySQL, but for us, we were doing multi-process. We were being explicit about everything, and it was still horrible because our network queue was broken, which was our own damn fault because we tried to import it to MySQL. So that was a little side note because I wanted to actually say concurrency is hard. Dynamic languages, they're fast and fun for programmers. Like you can get things done.
What were
That's
the
why I like
dynamic ones you said?
Python, Perl, Ruby, Visual Basic, PHP, JavaScript. There are languages in which you can say A equals something, and then A equals something else of a different type, and that's totally okay. They're dynamically typed. That's why I'm calling them dynamic. Static versus dynamic typing is not the one true method to split languages apart, but it's the method I'm using right now.
Okay, I was thinking the two were interpreted versus compiled.
Right, well, and that's confusing too, because a lot of interpreted languages like Python, there's a compiler. It gets compiled to an AST, which is interpreted. And C#, where do you put C#? Is it compiled or interpreted? Where do you put Java? Is it compiled or interpreted?
Pseudo-compiled.
Right, they both have compile steps. And then they have a virtual machine in which they run. And Python is just like that. Fundamentally, there's not a huge difference between Python and Java in terms of compilation. They both compile to an intermediate language that gets run in some sort of interpreter. Okay, so not all dynamic languages have trouble with concurrency, but Python, Ruby, JavaScript, Perl all have concurrency issues. Python is where I come from, so I can bitch about it the most. It has a global interpreter lock. The global interpreter lock locks the whole interpreter. So if you have multiple threads running, don't care, I got a lock. I'm gonna block everybody. And the Python global interpreter lock only gets used in rare cases, like when you reference or dereference an object. So, hardly ever. I mean, every single line of code. Threads are, in all of these cases, threads are also expensive. If you want to have 1 million open connections, if you open 1 million threads, you're going to use up a lot of memory. And then they all have, like, in spite of Twisted being nicer than just straight callbacks, there's still callback hell. Twisted did not get rid of callback hell. I can't really talk about what's wrong with concurrency in Ruby. Well, Ruby has an even worse global interpreter lock than Python. Even worse. All of them use threads. Threads suck. Python has things like greenlets, and there are things that people are trying to do. But in the zen of Python, well, I'll get to that. Okay, so dynamic languages are great for programmers, except that concurrency still sucks. So they're not great for programmers who want to do things concurrently. Statically typed languages don't have, by and large, don't have global interpreter locks. I can't think of one that would have something quite like the global interpreter lock. Java and C#. People use threads all the time. They're better. I have written a bunch of threaded code in Java and in Python, which is just a layer on top of Java, and is way better than threaded code in CPython because there's no global interpreter lock. But it's still painful, and you still have this thing that between any two lines of code anywhere in your program, magical things can happen that you don't know what they are. Like a variable that got passed in, it could have changed somehow. Ideally, you don't use things that are not local variables in your functions, but come on. Who has ever written a program with functions that never ever did anything except with things that were passed in? They don't touch anything else, just stuff that was passed in. Yeah, see, it's hard.
Or you talk not using global variables.
Not using global variables or module local variables or variables that are in any way that live past
The function itself.
the function's lifetime.
So you're also saying not using basically class properties as well?
Class properties, right? Any kind of attribute on an object that exists before or after the function,
Mm-hmm.
that thing can change. It can mutate in the middle because some other function somewhere else got called by a thread and did something to it.
Yeah.
This goes back to Python because Python. I wrote or worked on a web framework called TurboGears, and TurboGears basically mapped objects to URLs and let you go into them, but those objects had to be immutable. Because if you had an attribute to one of those, a property on a class or on an object, then that could easily be being executed in two different threads at the same time. That change could happen between the beginning of the request and the end of the request, and you get a different value than you expected. And we went through horrible meta-class hackery machinations to prevent people from doing something that was going to shoot them in the foot. But it was painful, and they still shot themselves in the foot because they figured out ways around our meta-class hackery. Which, now you have two problems. You have concurrency and meta-class hackery. It was a bad idea. Functional programming, though, is great. It solves all of these problems because everything is immutable. You cannot mutate any of your data structures, ever, period. Which is conceptual.